Good morning, boys and girls, and welcome back. Today we're talking about volumes of solids of revolution, and we're going to revolve our functions today around the x-axis. So in our first example here, we're dealing with 4 root x, this graph right here, and we're going to want to take this and we're going to revolve it around the x-axis. It's kind of hard to show, but maybe this will help a little bit. Let's say that's like the underside of it, of the shape, and then if I took like some point and I revolved it around, kind of give you an idea of this solid here, right? Maybe just a little bit. Let me pull some up and might give you a better picture too. Okay, so I found that this little app or website kind of helps me visualize what's going on a little bit better. Same thing here in the red line. Now we have our graph 4 root x, right? And we're going to revolve this around the x-axis. So if I do that, it'll take and I'll start revolving it, and you can kind of see it going here. If I move it, you can see what it's doing. It's kind of taking it and going around the x-axis. And as we're moving the function around the x-axis, it is creating a solid. Another view of it here as it kind of comes around. See, you can kind of see our solid here. A bit better. Turn it back to the beginning, let it finish up here. I think it's going slow because of our recording. It's not quite solid. I'm going to pause it and I'll let it finish. Okay, so now it's finished, and I'll drag it around here so you can kind of see it. But this is what we're doing. We're revolving it around the x-axis to form this three-dimensional shape, this solid with a volume. All right, we'll see if we can do it again a little bit faster this time. All right, we're back at the beginning and revolve. So it's coming around, coming around, coming around. And we're getting our three-dimensional shape. So this is what I was trying to draw on the board, okay, is this three-dimensional, looks almost like a bullet tip maybe or something like that, but we're going to try to find the volume of this shape. One more time maybe. I'll let it go from starting just going around the backside, all the way up. But we're trying to find the volume of this solid. So I hope you kind of have an idea now, a little better picture in your mind of what we're trying to do, because I think that does help with this stuff a little bit. All right? So there is the solid that we were trying to find. All right, so hopefully you got the idea of what I'm trying to illustrate here with the demonstration we just had. Okay, but we're revolving a function around the x-axis to create a solid with volume. And then if we take just a little slice of this, like where that green line is, it kind of creates a disk. All right, and that disk we're going to try to make infinitesimally thin. Okay, so that we can do a bunch of these together to, if I added up all those disks, that would give me the volume of the shape. All right, and the way we do that, the formula we're going to use to do that is the volume is going to equal the integral from A to B, wherever you're going to start and stop, because it's a disk. This is called the disk method because we're using a disk. But that's a circle, so if I took all those areas of the disk, so pi r squared dx, then that'll give me the volume of our shape. Okay, so I just remember we're trying to do a disk is a circle, so pi r squared is our formula for the disk method, A to B. All right, and then again, where the radius, right there, right, that is the y value on the function, or the y value or the f of x, that is going to be equal to the radius. All right, so now let me give you an example, and let's actually work through one of these things. Okay, so on these problems, I'll always tell you exactly what you're trying to do. So in this case, we're going to take the area enclosed by the functions y equals negative x plus 1, x equals 0, and y equals 0, and we want to revolve it around the x-axis. They'll always have that written out in words. All right, so we're going to take this function here, and I want to revolve it around the x-axis, and it would kind of create like a little cone-looking shape. Okay, so just give you, again, a real quick view of what this would look like. If I take our line, y equals negative x plus 1, x equals 0, which is the y-axis, and y equals 0, which is the x-axis, and we take that area here, and now we're going to revolve this around the x-axis, we would get a shape that kind of looks like this. And it ends up kind of being a cone, or the top of a cone. so hopefully you get an idea now of what this kind of looks like here. Alright, that might be the best view there. Alright, so now let's go find the volume of this. Alright, I'm using another program because obviously my drawings are not quite as good as that is, but I think it really does help. Give yourself something to kind of try to visualize what's happening, and usually you can do better on a piece of paper. The computer drawing this has been a little bit difficult for me, but you want that visual of kind of what's happening. Alright, so now I need to go ahead and I'm going to use my formula to find the volume of this. Alright, so our formula is, again, the integral from a to b of pi r squared dx. So I need to know where we're going to start and stop this. Obviously, we are starting at 0 because we're bounded by x equals 0. And then I got to go to wherever this is crossing right here. So I need to find the x-intercept. So I might come to the side, 0 equals negative x plus 1, and set that equal to 0. And so I get x equals positive 1. And so that's where it's going to stop. So I'm going to go from 0 to 1. Pi, again, r is our function. All right? So the function in this case is negative x plus 1 squared dx. But that value that I'm going to go up is just the y value. So we generally use the function for our r. And so that would be the setup that I'm going to do right here. Now if I were integrating this by hand, I would pull the pi out to the very front here, and I would multiply out this so that I could just use the power rule to integrate it. Probably easier than using u sub, although I guess you could if you wanted to. Then you're going to go ahead and take your antiderivative right here, and then you're going to be able to use the fundamental theorem to evaluate. So just be careful when you plug in and everything. Use correct grouping symbols. I plugged my 1 minus. If you plug in 0 and it's going to be 0, you can just write 0 like that. You don't have to actually go and plug in 0. But then you're going to simplify, and in this case we should get pi over 3 is the volume of our shape. Alright, and then I guess if you want to, you could go and verify that using the formula for the volume of a cone. 1/3 pi r squared times the height. Oh, and that would also be pi over 3. Interesting. Okay, moving on. Next example. Alright, for our next one here, same idea. We are going to take y equals 4 minus x squared, the area enclosed by that, by x equals 0 the y-axis, and y equals 0 the x-axis, and we are going to revolve this around the x-axis. So 4 minus x squared is a parabola that's opening down. Would look something kind of like that, maybe, right? And so I'm going to take this region, and we're going to, again, revolve it around the x-axis. So, you know, revolve it around like that. So it might look something like, you know, this shape might look something like that. Hey, gives a rough deal. Again, when I set this up, I'm going to want to go integral a to b of pi r squared dx. Right? So I now need to figure out, we're starting at 0 and going to some value right here that I go figure out. So I would take my function and set it equal to 0. And you're going to get x equals 2. Plus or minus 2, but obviously we're on the positive side. Alright? Pi times, again, the radius is the function itself. It is that y value. So 4 minus x squared dx. And now, again, you would just work this out by hand, which we should be able to, or you could plug this in your calculator. For the sake of time, I'm just going to, I'll do some quick work real fast, but I'm going to just put the answer from the calculator on in a second. All right, here's what I'm going to say. I'm not going to spend a lot of time talking about how to integrate these things, but this is something that we should be able to do by hand. Okay, you'd want to FOIL out, you know, reverse power rule. Frequently when these are graded, I'm going to look at your antiderivative here that you're going to get points from, but you should be able to work this out and get to 256 pi over 15 by hand. Okay, you can check yourself with the calculator if you want to or need to. All right. Now, that's disk method. Let's move on and talk about washer method. Actually, after thinking about it, I'm going to stop this video right here, and I'll pick up the next video with washer method. That way I make sure I have plenty of time to finish everything. I'll do 2 short videos this time. Alright, thanks boys and girls, and catch you with washer method.